first problem in the 7.3 homework is number 59, and it's a partial fractions problem. So we're gonna factor the denominator into x times x plus 1, and then we're going to make two fractions out of each factor in the denominator, and we're going to propose two variables to stand in as the numerators for these two fractions. A as a numerator for the factor x, plus b as the factor for x plus 1. The idea being, when we end up with these two fractions, if we add them back together again, we should end up with 1 over x squared plus x. So we simply create the two fractions with the variables a and b, a over x plus b over x plus 1. The next step is to put the two fractions back together again. So the numerator in a over x is multiplied by x plus 1, and the numerator b over x plus 1 is multiplied by x. So now we have a times x plus 1 plus b times x over x times x plus 1. We distribute, and we have ax plus a plus bx over x times x plus 1. Factor the x out of the two terms, ax and bx, and we're left with x times a plus b plus a. Okay, so when we were setting up the problem in the first place, we said that there would be, there was the coefficient for x in the numerator was 0. There's no x's, and there was just the one number as a constant. So a plus b as a coefficient of x in this fraction right here equals 0, because that's the coefficient of x. There are no x's. So a plus b equals 0. And that leaves a, which is all by itself here, to equal 1. So a equals 1 and a plus b equals 0. We then solve the system of equations, and we get a equals 1, then b equals negative 1, because 1 minus 1 equals 0. And the two fractions we're left with is 1 over x minus 1 over x plus 1. Now, to make sure that we did this right, let's just check it real quick. So we'll cross multiply to make one fraction. So we'll have x plus 1 minus x over x times x plus 1, and that equals 1 over x times x plus 1. The next problem is more of the same. We got 3 over x squared minus 3x. The numerator is 0x's plus 3 over x times x minus 3. So there's just two distinct factors. So we'll have a over x plus b over x minus 3 are our proposed two fractions. We're then going to take these two distinct fractions and join them together by cross-multiplying the denominators. We eliminate parentheses, combine like terms, and factor, and we end up back here at x times a plus b minus 3a over x times x minus 3. So once again, a plus b is the coefficient of x. There are 0 x's. As you can see, there's no x's in the numerator. Whereas minus 3a equals 3. So a has to equal negative 1, b has to equal 1, and we're left with negative 1x plus 1 over x minus 3. 62. We have two factors, x plus 3 and x plus 1 in the denominator. This time the coefficient of x is 1, and then negative 2. We make the two fractions, a over x plus 3, b over x plus 1. Cross multiply and make one fraction. eliminate parentheses, combine like terms, and factor. And we're left with a plus b is the coefficient of x, which equals 1, and a plus 3b equals negative 2. Now we have a true system of two equations, and you just simply go through the maneuvers of solving that. I eliminated a. Minus 2b equals 3, b equals minus 3 halves. A is going to equal 5 halves. And so our two fractions are 5 over 2 times x plus 3 minus 3 over 2 times x plus 1. 63 has three factors, x, and then x minus 2 times x plus 2, as we get from doing the factoring, over x plus 6 squared. So we're going to have a plus b plus c, a over x plus b over x minus 2 plus c over x plus 2. We do the cross multiplication to join. To join them all as one fraction. I don't have the denominators in here because it's just redundant to have them over and over again. I eliminate parentheses, combine like terms, and I come up with three coefficients. I have a coefficient for x squared and a coefficient for x, and then the constant, the loose constant. So I have a system of three equations where a plus b plus c equals 1. That's the coefficient of x squared. Okay, it's x squared plus 12x plus 36. 3b minus 2c equals 12. And let's see. This is an x plus 6. I don't know why the heck I did this. This is a mistake. Anyway. So we have the three coefficients are 1, 12, and 12. Okay. So minus 4 equals 12. 3b minus 2c equals 12. I solve the system of equations, and I end up with negative 3 over x plus 5 over x minus 2 minus 1 over x plus 2. And then finally, there's three curve fitting problems. Y equals ax squared plus bx plus c is the model. We have 3 points. And so with these, we can make a system of equations and then solve for a, b, and c. A, b, and c being the constants that we want to find. So 0, 0 is a point. Now what we're going to do is plug in 0 for x. So we got a times 0 squared plus b times 0 plus c equals 0, because we put in 0 for y. Well, you can see that c equals 0. So that part's finished. Next step, we're going to take 2 for x. So 2 squared is 4. 4a plus 2 times x, 2b, equals y is negative 2. And then we got 4, 16a ax squared plus 4b equals 0. Solve the system of two equations. It's pretty easy. And we get a equals 1/2, b equals negative 2. And the final equation, of course, c is 0. 1/2 x squared minus 2x. 78 is more of the same. Make the three equations. Again, we have 0 for x, so c equals 3. So that's done. So we're going to have A plus B plus 3 equals 4. So A plus B equals 1. So we take 1 and plug it into AX squared plus BX plus C equals Y. We plug in 1 for X. So we get AX squared, that's A, 1A, plus 1B, plus C, 3 equals 4. So A plus B equals 1. And then we plug in 2, so we get 4A plus 2B plus 3 equals 3. So 4A plus 2B equals 0. And then we're going to use A plus B equals 1 to solve the system. Now we have a system of 2 equations. And we end up with A equals -1 and B equals 2, along with C equals 3. Negative x squared plus 2x plus 3 equals y. And then 79, you do exactly the same thing. Now, because, well, I decided to do 79 using RREF. And so you can follow it along here. I set up 4, 2, 1, 0 as the coefficients for the first equation. 9, 3, 1, -1 as the numbers in the second equation, and 16, 4, 1, and 0 in the third, after plugging in these points. And then I use the RREF method to end up with, eventually, I get C equals 8, and then I'll use that to get B equals -1, and A equals 1. Okay. And these are my row maneuvers here. -2 times row 1 plus row 2 gives me this. -4 times row 1 right here plus row 3 gives me this row. And 9 times row 1 minus 4 times row 2 gives me the third row here. And then the only other maneuver I have to make in order to finish this off is the third stage. I take 3 times row 2, this row right here, plus 2 times row 3, and combine them. And that gives me the solution for C. And from that I can calculate everything else. Okay, so that's it for 7.3.